welcome to Translators and Facilities of Languages Part 2, taking a closer look at translators. So we're going to be looking at assemblers, compilers, and interpreters today, and especially concentrating on the advantages and disadvantages of the latter two. So let's start with assembly language. So what we should remember about assembly language is that it's a low-level language that is very close to machine code. So if you look here, we've got some machine language, some machine code here. We've got the opcode and we've got the operand. It's all binary ones and zeros. And when we look at it in assembly, we've made a few changes to it to make it easier for people to recognize and work with. So we've changed the opcode of 10110000 to MOV-AL, and we've changed the operand of 0110001 to 61H. So this is still difficult to understand, but it's a bit easier for people to parse because we are using letters and numbers that we're more familiar with. So in this example, it's an instruction to move a value from a location in memory to the accumulator. So instead of the binary, we can say MOV-AL, which means to move the value. And then we've got the location in memory of 61H. That's a bit easier to understand than ones and zeros, although it's still a little bit complicated. And the idea here is there's a one-to-one relationship between the opcode in the machine code and the assembly, so it's easy to convert between them. So again, if the binary is replaced by a suitable mnemonic, for example, move-al, it becomes easier for programmers to work with. It also, if we convert the operand to a hexadecimal value, the instruction becomes much more memorable for the programmer. So here, the value 61 is in hexadecimal. That would translate to the decimal of 97, I believe, and the H just means it's hexadecimal. Remember, it's very easy to convert between binary and hexadecimal, so it's quite good to put the value in this form. Again, one machine code instruction maps to one assembly language instruction. However, the assembly language still needs to be translated, converted into machine code. And that's what an assembler does. An assembler is just the software that takes our source text file written in assembly and converts it into binary machine language so that it can be understood. So an assembler is just the software that takes the low-level assembly code and translates it into pure machine language. I hope that's clear. Let's take a look now at compilers and interpreters that do the same thing but for high-level languages. So basic points here, high-level languages are much more like human languages and make writing and maintaining programs easier. So that means anything like Python or Java or C++ or any other language that I'm sure that you're familiar with. Each high-level instruction will generally represent several machine code instructions. So you might write one line of Python or one line of Java, but when that is then converted into machine code, it might be several instructions. Again, high-level language programs need to be translated into machine code before they can be executed. A compiler will translate the complete program from the source code into machine code in one go. So it'll take whatever the program that's been written in Python or C# or whatever, and then in one go it'll go through it and translate it into machine code. A compiler reads all the source code in one go, examines each keyword and their arguments, and it translates all those keywords into a set of machine code instructions. As I said before, each keyword often translates into more than one machine code instruction. It's not like assembly, which has this one-to-one relationship between itself and machine code. With a high-level language, you don't have the one-to-one relationship. The translator has a bit more work to do to take each instruction and work out how to do it step by step in machine code. Once the code has been successfully compiled, it is stored as an executable file. An executable file is one that can be run without the compiler or the source code being present. And we're familiar with executable files. In a Windows system, they'll have a name and then it'll be .exe. And these are the files that we run most of the time when we're running programs on our computers, .exe files. So those are programs where the source code has been compiled and then the company releases that file for people to run on their computers. Just a kind of side technical note here, a little bit of extra. Often large programs are often broken down into several software modules. Each module is compiled into what we call an object file. And then these object files are all linked together into one executable file right at the end of the process. So that's maybe a bit more information than you need to know, but I just like to give you that little bit extra. Okay, an interpreter. An interpreter does a similar job to a compiler in that it converts the high-level source code into machine code. However, unlike a compiler, it doesn't do this all at once. An interpreter translates each line of high-level code into the equivalent machine code and then immediately executes it before translating the next line, and it carries on doing this until the program is terminated. So with a compiler, it looks at your whole program and then compiles it all into the executable machine code. With the interpreter, it looks at one line, converts it, reads the next line, converts it, and so on and so forth. And it's reading each line by line after it's been converted. An interpreter must always be present to run the source code. Also, the source code itself needs to be available. So remember, the compiler, once it's finished, leaves you that executable file that can be run by itself. With an interpreter, you always need the source code and the interpreting software to run your source file and run it in a way that the computer can understand. So why do we have two different models? Why do we have interpreters and compilers? Well, they have different advantages and disadvantages. So we start with the advantages of an interpreter. Since it translates a line at a time, it is easier to debug the code, find and fix errors. That's because errors are reported line by line as they're processed. Interpreters are also useful for experimenting with code because you don't need to recompile the whole program every time you want to make a change or experiment or run it. The program can also be run on any machine for which there is a suitable interpreter. So as long as there's an interpreter running on that machine and you have the source code present, you can run the program. There are also disadvantages to interpreters. So for example, the code runs more slowly than compiled code because it needs to be translated each time it is run. The source code also has to be available to the user before they can run the program, which means a user can view the code, modify it, look for problems, change it, edit it, things like that. In some cases, that might be what you want, but often big companies like to protect their source code, so they only give you the compiled executable version and they keep the source code to themselves. The user requires a copy of the translator in memory. So whenever you're running an interpreted program, as well as the source code, you need to run the interpreter. And this takes up memory, it takes up CPU processing time, so it's a bit more slow than a compiled program. Also, the code doesn't get optimized. One of the things a compiler does is, well, hopefully a good compiler will optimize the code and make it run a little bit faster. Because the interpreter does it line by line, it doesn't really have the same facilities to optimize code. So, advantages of compilers. So an executable file is almost unreadable, making it very difficult to modify the program or copy its ideas. So if you've got an executable file, you can view it, but you're basically getting a set of machine code instructions. It's very difficult to go from that back to the high-level version that is easy to edit. Compiled code runs faster than the same code that has not been compiled. There is no need for the translator to be in memory to run the code. This saves memory, storage, and possibly cost. Because compilers look at the whole code all at once, they can look for common patterns and ways to optimize it to make it more efficient and effective. But there can be problems with compilers. When you're developing the code, it has to be recompiled every time the code is changed, and if you're dealing with a big program, that can take quite a long time. You cannot try out individual commands to see their effects. A compiled program is specific to a particular processor and will not work on another type. So once you have that executable file, it will only run on that family of processors. Compilers don't report errors until the end, so until after the end of the compiling process. Then they report the errors right at the end.